Hi guys, welcome to Chakra Science Academy, just a minute series where every minute counts in unlocking the secrets to master your board examination. Today we will talk about structure of glucose. I'm going to give you a trick
Hey, y'all, come look at this.
trick which you will remember for the exam, how to draw the structure of glucose by this, which और मत समझ लेना. Alright, so let's see the structure of glucose. How do we remember? So you need to remember this picture. You can see that in this picture, you need to see the third finger. The third finger is outside and all the fingers are closed. It means the third carbon, if I give the meaning, you have to focus on the third carbon. The OH where the finger is out is on the left side. Rest all the OH group is on the right side. We know the glucose has 6 carbon. The first carbon will be a aldehyde group, and then the last one is a 1 degree alcohol that will be the 6 carbon CH2OH. Rest all are 2 degree alcohols, where only the third one you have to focus that the third carbon which outside, this finger is outside, that means it's on the left side, rest all are on the right side. So this is the structure of D-glucose. So now let's draw it. So first of all, the first carbon, that will be a aldehyde carbon. The last carbon is 1 degree alcohol, that is a CH2OH. In between, there will be 4 chiral centers where the first, second, and third. Third one will be on the left hand side, and rest all the alcohols are on the right side. Moreover, you can see the other side, there will be a hydrogen. So this is your third carbon, fourth carbon, fifth carbon, and sixth carbon. And you can see the second last carbon is special. When second last carbon is on the right hand side, we call it as D-glucose. Now you need to remember it's a uppercase D. It means when OH is on the right, it's called D-glucose. When OH is on the left, it's called uppercase L-glucose. Because there is a difference in uppercase D and lowercase d. When it's a lowercase d, it means it's dextrorotatory. That we will discuss in the next video. And when it is lowercase l, it's levorotatory. So for now, you need to remember the second last carbon, or you can say the last chiral carbon, when OH is on the right, it's called D-glucose. If OH was on the left, it would have been called as L-glucose. Now we will see, using this structure, the basic structure, how can we make a ring? So now already we have a, Fisher projection, which is a simple structure of a D-glucose we have learned using this trick, where the third finger is outside. That is why the third carbon, OH is on the left, rest everywhere, the OH is on the right. Okay, so now let's see how do we make it a ring. So what is the first thing we will do? We can see here in the aldehyde group, the oxygen is more electronegative. It will take up the pi electron. So there will be a negative charge, and on the carbon, you will have a positive charge. Now look at the second last carbon. The oxygen is having a lone pair. Actually, all the oxygens have a lone pair, but we select the second last carbon. Second last carbon, oxygen atom will donate the lone pair to this carbon, C plus, and the hydrogen will go to the O minus. Now the question arises, why are we choosing it? The alcohol group oxygen atom lone pair only from the fifth carbon. Why we are not choosing from the other carbon? The reason is because we will make a six-membered ring, and six-membered ring is very stable. Okay, that is the reason we are selecting the OH group from the fifth carbon. So this oxygen atom will donate the lone pair to the C plus, and hydrogen will go to the O minus. So now let's see what is the structure we will get. So you can see here, first this carbon, the first carbon will have a hydrogen. And because this oxygen has taken the hydrogen from the fifth carbon, so on the right side we will write the OH. And on the second carbon, there is nothing happening, so we will copy it as it is HOH. On the third carbon, what is going to happen? On the third carbon, we will take the same OH is on the left, so we'll take it like this. Okay, on the fourth carbon, what is happening? Look at the fourth carbon. Same, we'll copy this. Now, on the fifth carbon, sixth is as it is, CH2OH. Okay, now what is happening at the fifth carbon? Let me give the numbering so there should be no confusion. 1, 2, 3, 4, 5, and 6. So, what is happening at the fifth carbon? At the fifth carbon, you can see there will be a hydrogen, but this oxygen is bonded to this carbon, the first carbon. So, the first carbon will have a ether bond here with the fifth carbon. You can see that. So, now we can see that we have made a ring of 5 carbon and 1 oxygen. You can see it's already a ring-like structure, and now we will convert it into a 6-membered ring. So I think you have got the logic why we are selecting only this oxygen atom lone pair, because in order to make a 6-membered ring, 6-membered ring is highly stable. That is the reason. Now we're using this structure, we will finally get the ring structure of the D-glucose. All right, so let's make the glucose ring structure. We have already seen now that it is going to be a 6-membered ring where 5 carbon and 1 oxygen is going to make a 6-membered ring. So 6-membered ring means let's construct a hexagon. So it's going to be 5 carbon and it will be 1 oxygen. The rule is the oxygen should be on the top right, and rest all the horizontal bonds will be now vertical, will be placed now vertical in the ring. Okay, and which will be the carbon number 1 to 6. So remember, you have formed the oxygen, you have to go clockwise. So this will be your first carbon, this is your second carbon, this is your third carbon, this is fourth, this is fifth, and finally the sixth one will be on the fifth carbon. You can see the fifth carbon has the sixth carbon and a hydrogen. So the bigger group is written above. So the sixth carbon is here attached to the fifth carbon and the hydrogen is here. Now, one more thing you need to know, in horizontal bond, whatever is on the right will be written below. So this will be written below, and whatever is on the left in the ring structure will be written above. This is very, very important. You have to remember. So let's do it now. On the first carbon, the OH is on the right. That means the OH will be below. So hydrogen will be above. Same story for the second carbon. OH will be below. We know the third carbon is on the left, so it will be written above. And the hydrogen will be here. Fourth carbon, same story. The OH is on the right, so it will be written below. And we already know fifth carbon, the bigger group is written above. That is why CH2 is the on the above. And this is presenting you the D-glucose ring. This is your D-glucose ring. One more thing, remember, at the first carbon, when the OH is below, then it's called alpha D-glucose. And when the OH is above, it can be above also, then it's called beta. So this is basically a alpha D glucose. Now, how alpha and beta has come up, that we will discuss in the next video. So bye bye, and don't forget to share with the friends who need it.